Good morning, welcome to new lecture. Today I will talk about scalar and vector. What is the scalar quantity, what is the vector quantity? Let's look at today scalar quantity versus vector quantity. Scalar quantity usually we can describe using only magnitude. So scalar quantity can be described only using magnitude. Vector quantity can be described using magnitude and direction. So, any quantity we can describe using only magnitude, we will call it scalar. Any quantity we can describe using magnitude and direction, we will call vector. For example, distance. Distance, for example, 5 miles. We can describe using magnitude 5 miles. 5 miles to the north, east, west, it is not important in the distance. So, distance it is scalar quantity. But how about displacement? Displacement, it is vector. Because, for example, 5 miles to the east or west or north. So displacement is vector. You need magnitude and direction. For distance, magnitude only it is enough. So it is a scalar. Another scalar, for example, is speed. 30 miles per hour. We call it speed. Magnitude is enough in order to describe. But velocity is vector. Because, for example, 30 miles per hour to the north or east. So you need magnitude and direction. Mass. You need only magnitude, so it is a scalar. But force, you need magnitude and direction of the force. So it is vector. Temperature. Temperature you can describe only using magnitude, so it is a scalar. For vector I can give another example. For example, acceleration. Acceleration you need magnitude and direction. For a scalar, for example, volume. It is a scalar. Time. Area. These are good examples for scalar quantity. These are for vector quantity. So now we know what is the scalar, what is vector. Scalar is answer for the question how much, how big, how many. For the questions like how much, how big, how many, scalar quantity is the answer. But for vector quantity you need another question. The answer for the question how much and which way. For example, force. We apply 2 pounds, but in which direction? So it is vector. So the answer for the questions how much and which way, it is vector quantity. The answer for the how much, how many, how big, it is scalar quantity. After we know what is the scalar, what is vector, let's look at the vector operation. How we will add 2 vectors, how we will subtract 2 vectors. So I can say vector operation Of course, here first I will explain using graphical method. So, vector operation using graphical method. Vector operation using graphical method, usually we can add or subtract two vectors using parallelogram law. And or triangle rule. Both are similar. Assume we have two vectors like vector A and vector B. We want to add these two vectors. We want to find resultant vector is equal to vector A plus vector B. So vector addition. How we will add these two vectors? Using, for example, triangle rule, you will show first vector A. You can draw one line parallel to the vector A, and the length exactly, it is identical to the vector A, and the sense of vector, it is in the same direction. So this is identical to vector A. From the head of this vector A, you will put the tail of vector B, and you will draw another vector identical to vector B. So again, the length or magnitude should be equal to the vector B, and the sense of vector should be in the direction of vector B. Another vector which attach the tail of vector A to the head of vector B, it will be resultant vector R. So here resultant vector R is equal to vector A plus vector B. Here you see the shape we have, it is triangle. So we add two vectors using triangle rule. You can make parallelogram. In order to make parallelogram, you will draw vector A. Then from the tail of vector A, you will put vector B. Then from the head of vector A, you will draw one line parallel to the vector B, and from head of vector B, you will draw another line parallel to vector A. The vector attaches the tail to here, to this intersection point. It will be resultant vector R. You see here shape we have, it is parallelogram. So we add two vectors using parallelogram law. Using the triangle rule or parallelogram law, we can subtract two vectors. For example, again, we have vector A and vector B. What is the resultant vector? A minus B. Again, first you will draw one vector, same as vector A. Then, let's show a little bit, I need space here. You will draw one vector like vector A. Then you will multiply vector B to the scalar -1. If you multiply this vector to the scalar -1, the length of vector will be the same. The sense of vector direction will be in the inverse direction. So this will be negative vector B. Now we will put the tail of this vector to the head of vector A. This will be negative vector B. Resultant vector will be this vector. So this vector will be vector A minus vector B. Or for example, let's find this vector, vector 2A plus 3B, for example. In that case, you will multiply vector A to the scalar 2. It means the length of vector, it will be 2 times of vector A, but the direction will be the same. You will multiply vector B to the 3, so the length will be 3 times of vector B. And again, you will follow triangle rule. This will be 2A plus 3B. If you have more than one vector, for example, you have 3 vectors or 4 vectors. You have vector A, vector B, vector C. How we can find the resultant vector? A plus B plus C. You can again follow, for example, triangle rule or parallelogram law. You will choose first 2 vectors, vector A and vector B. You will find the resultant vector for A and B. Then you will add this resultant vector to this vector C. Again, you will make another triangle. This will be, for example, R1. This will be R total. It means vector A plus vector B plus vector C. So even if you have hundreds of vectors, 2 by 2 you will add together and you will follow triangle rule or parallelogram law. Here another things I should review. Of course you know about that, but we will use it if we want to add vectors using triangle rule or parallelogram law. You will need the 2 laws we know. One of them it is law of cosines, another law of sines. For example, if we have one triangle, this is the length, for example, it is A, B, C. These are lowercase. This angle is capital C, this angle is capital B, this angle is capital A. So we have this triangle, this side length it is A, this side length it is B, this side length it is C. The angle in front of C it is capital C, in front of B capital B, in front of A capital A. What is the law of cosines and what is the law of sines? Let's first I will write the law of cosines. Using law of cosines, we know C squared is equal to A squared plus B squared minus 2AB cosine C. Or I can write in another way, I can write cosine of angle C is equal to A squared plus B squared minus C squared divided by 2AB. Cosine B is equal to C squared plus A squared minus B squared divided by 2AC. Cosine of angle A is equal to B squared plus C squared minus A squared divided by 2BC. You can write in this form or you can write in these forms. This is law of cosines, we know that. Another law, it is law of sines. Let's see what's the law of sines. The law of sines. In one triangle we know A divided by sine A is equal to B divided by sine B, that is equal to C divided by sine C. you should know the law of sines and law of cosines in one triangle, because whenever we want to find the resultant force for force system using triangle rule or parallelogram law, you will need to know this. Let's look at today vector operation in Cartesian form. So, vector operation, I can write Cartesian vectors and operation. Cartesian vectors and operation. If we have Cartesian coordinate, for example, in 2 dimension, this is x, this is y direction, or we have Cartesian coordinate in 3 dimension, x, y, z. So, in 2 dimension, for in plane system, we have 2 direction, x direction, y direction. In 3 dimension, real life problems, we are living in real life in 3 dimension because we have x, y, and the z direction. So let's see if we have vector in 2 dimension and 3 dimension, how we can decompose vector and what are the vector operations. Let's focus first for the 2 dimension, 2D system. If we have one vector like vector A and this angle is alpha, we can decompose this vector in the x and y direction. This will be ax, this will be ay. Ax means we decompose vector A in the x direction. Ay means we decompose vector A in the y direction. Here ax magnitude will be a cosine alpha and ay will be equal to a sine alpha. And we can represent vector A length in terms of ax and ay. In that case, the length for vector A will be square root of a x squared plus ay squared. In this triangle, this is ax because this side is ay and this is kind of rectangular shape, so this is ay to this length. So in this triangle, we can write tangent alpha is equal to ay divided by ax. Let's see if we have vector A in 3 dimension, how we can decompose this vector in 3 dimension. So in 3D system, in 3D coordinate, x, y, z direction, this is vector A. We want to decompose vector A in the x direction, ax, in the y direction, ay, and in the z direction, az. So if the angle of vector A with the x-axis, if it is alpha, and the angle of vector A with y-axis, it is beta, and the angle of vector A with the z direction, it is gamma, we can write ax is equal to a cosine alpha, ay is equal to a cosine beta, and az is equal to A cosine gamma, or we can write cosine alpha is equal to AX divided by A, cosine beta is equal to AY divided by A, cosine gamma is equal to AZ divided by A. And if we define unit vectors means the length of vector is equal to the unit, is equal to the 1. The unit vector in the x direction will be I. The unit vector in the y direction will be j. Unit vector in the z direction will be k. So I can represent vector A is equal to AXI plus AYJ plus AZK. From here I can write, because the cosine alpha is equal to AX over A, and cosine beta is equal to AY over A, and cosine gamma is equal to AZ over A. I can write cosine square alpha plus cosine square beta plus cosine square gamma is equal to 1. Why I can write this? Why? Let's see. Here, if I represent vector A in Cartesian vector form in terms of unit vector, as I mentioned, I is unit vector in the x direction, j is unit vector in the y direction, and k is unit vector in the z direction. And unit vector means the length of that vector, it is equal to the unit, it is equal to the 1. So if I represent vector A in Cartesian vector form, it will be AXI plus AYJ plus AZK. From here, the length of this vector will be equal to square root of AX squared plus AY squared plus AZ squared. Why? Because if you look at here, this is AX, this is AY. So this length again, it is AY. So from the origin point O to here, this length, I made it bold. If I show that with A prime, in this triangle, I can write A prime is equal to square root of AX squared plus AY squared. So in this triangle, this is AX, this is AY, so A prime will be equal to square root of AX squared plus AY squared. Now if you look at today this height, this is AZ, and this height should be equal to the AZ2. So this is A prime, this is AZ. How about this length A? In this triangle, I will make it red here. You see, length of A will be equal to square root of A prime squared plus AZ squared. If instead of A prime you plug this here, you will get the length for vector A. If we calculate using the component of vector A in the xyz direction, will be square root of AX squared plus AY squared plus AZ squared. Now if we write instead of ax is equal to a cosine alpha, ay is equal to a cosine beta, and az is equal to a cosine gamma. If we plug these here, what we will get? We will get vector A length is equal to square root of, I should factor out a squared cosine square alpha plus cosine square beta plus cosine squared gamma. Now, if both sides I make square of both sides, this will be a squared is equal to a squared times cosine squared alpha plus cosine squared beta plus cosine squared gamma. These two, they will cancel each other. From there you can find finally cosine squared alpha plus cosine squared beta plus cosine squared gamma is equal to 1. Sometimes you know the angle of vector, for example with x and y direction. So the alpha and beta, they are known. We know alpha, we know beta. But problem statement doesn't mention anything about gamma. So using this relation you can find the gamma, or you know alpha and gamma, you don't know beta. You will plug here, you will find beta angle. Another important things I should here talk about that. I assume the unit vector in the x direction it is I, in the y direction it is j, in the z direction it is k. How about unit vector in vector direction? If I want to define unit vector in the direction of vector A, if I want to define one unit vector in the direction of the vector A, the length of that vector is equal to 1. That will be vector A divided by length of vector A. It means this will be equal to AX divided by AI plus AY divided by AJ plus AZ divided by length of vector AK. And because this is cosine alpha, this is cosine beta, this is cosine gamma, I can tell unit vector in the direction of vector A is equal to cosine alpha I plus cosine beta J plus cosine gamma K. Okay, now how we can add two vectors in Cartesian vector form. For example, you have vector A, and the component of vector A will be AX, AY, AZ. You have vector B, component of vector B will be Bx, By, Bz. What will be the resultant vector R, which is vector A plus vector B? You can write AXI plus AYJ plus AZK plus bxi plus byj plus bzk. From here we can write ax plus bxi plus ay plus byj plus az plus bzk. So how we will add two vectors or three vectors or n vectors in Cartesian vector form? You see it is very simple. We will represent each vector in Cartesian vector form. Then we will add I component, j component and k component together. How we will subtract two vectors? Again it is the same. For example, a minus b. This, in that case, you will represent vector a like this, negative vector b. So here, instead of positive, you will have negative. So this will be subtraction. Okay, I think this is enough for introduction. Briefly, I introduce what is the scalar quantity, what is the vector quantity, what is the graphical way in order to add or subtract two vectors, how we can represent vector in Cartesian vector form in 2 dimension, 3 dimension, what are the directional cosines, and how we can add or subtract vector in Cartesian vector form. Next session I will talk about how we will multiply two vector, how we will multiply vector A to vector B. So I will talk about dot product, then I will talk about cross product, and I will introduce you what is the position vector and what is the displacement vector. Thank you so much for watching this lecture. See you next session. Bye bye.